everyone, welcome to part 11 of my video series on statistical significance testing. So today we are going to talk about Kolmogorov-Smirnov test, which is case test, and as you can see, it's a very hard name to pronounce. So if I have pronounced it incorrectly, forgive me please. So this case test, it is very important if you are trying to compare two probability distributions. So without further ado, let's dive in. Let's try to understand how we compare two probability distributions and see whether they are significantly different or not. So before we talk about case test or probability distributions, we need to remember what is a CDF. CDF is cumulative density function or cumulative distribution function, whatever. Now, I've actually talked about CDF in my probability distribution series in the very first video. So I will leave a link of that in the description. But let me just remind you guys. So this blue line right here, you can assume that this is a probability distribution. And if you guys are familiar, this is a normal distribution. Now, it doesn't need to be normal distribution. It can be any probability distribution. But just for this example, I'm showing this. Now, for this blue PDF, probability density function, you can actually draw the CDF, which is the cumulative density function or distribution function, right? CDF. So you can see that the CDF stops at 1.0. Now, what does the CDF mean? Let me show you that. So let's just see this point right here in the CDF curve. So here you can see the value of x-axis is 0 and in the y-axis it is around 0.5. That means around 50% samples of this distribution, this blue distribution, have value less than 0. Okay, have value less than 0, or you can also say less than or equal to 0. Similarly, if you look at this point right here, it is in the 1 point, x equal to 1, and in the y-axis, the point is at around 0.85 mark. That means around 85% samples have value less than 1. So this entire thing is the CDF. Okay, so I think it is clear now. So the question is, what is ECDF? Because this ECDF or empirical CDF is something which we work with when it comes to, what should I say, the case test. So let's see how to get that. Suppose this is our data set 2, 4, 5, 7. These four values are there in the data set. Now, obviously, let me remind you one thing. In case test, if you want to work with some data set, it has to be large. Okay, so it has to be ideally, it has to have ideally less than, more than 30 samples in it. But for this example, we are just looking at 4 samples. So you can see that these are the x values 2, 4, 5, 7. Now understand that when we get the ECDF, we need to get these values sorted. Now this is already sorted here, but if it is not, then you need to sort it first. So after doing that, you can see that at 2, the ECDF of x is 0.25y because at less than or equal to, so how many values in x? How many values in x are less than or equal to 2? There's only one value, right? 2 is less than or equal to 2. So 1 out of 4. So 1 divided by 4 equal to 0.25. Similarly, if we take 4, you can see that there are only 2 values, 2 and 4, which are less than or equal to 4. So that means the ECDF of x will be 2 by 4, which is 0.5. So on and so forth. I think you get the idea. Now that you know the ECDF, let's talk about one sample case test, and there is also 2 sample case test. So what is one sample case test? It means, does my data follow a known distribution? Okay, so you have some data, so maybe you have 100 samples. Do my samples together follow a known distribution, and that known distribution can be anything. It can be normal, Poisson, uniform, or any distribution according to your liking. And what is 2 sample case test? It is nothing but comparing 2 data sets. So suppose you have 2 data sets, you have collected 2 sets of samples from 2 different places. So suppose you have collected 2 different data sets from 2 different places. So maybe you have collected heights from India and you have collected heights of people from America, and you want to compare these heights, right? So the question is, are those heights following the same distribution? That is the 2 sample case test. I hope you guys understand what I'm talking about. So this is an interesting plot. Let me first describe this plot, and then I will talk about the basic steps of case test. So suppose there are 2 distributions, maybe from 2 data sets or from 1 data set and from 1 known distribution. And these are the 2 ECDFs, right? So this is one ECDF of distribution 1, and this is ECDF of distribution 2. So if you draw both of those, then there is a certain place or there is a certain point where the distance is maximum, right? So you can see that here the distance is not maximum, here the distance is also not maximum. but here the distance is maximum. So this is basically the case statistics D. This is called case statistics D, and based on this we get the p-value. So let me talk about the steps now. So the first step will be to calculate the ECDF or CDF for the given datasets or distribution. So if you have two datasets, we are going to calculate two ECDFs. Then you are going to compare those ECDFs to get the highest possible distance. For example, this red line right here. Now, how you will actually get this is in numbers. I will show you that in later slides. And based on this D right here that you got, a number of samples in the data set, you are going to get the p-value. Now, this is very important. How many samples you have in the data set is very, very important. Okay? Because if you have more samples in the data set, then you are going to be more confident about your p-value, right? So a bigger D right here and more samples will give you more power and it will give you a lower p-value. And that means it will make you more probable of reaching statistical significance. Okay? I hope you have a clear idea about this now. So basically, if you have a bigger D, that means they are more different, right? So understand that each test has the null hypothesis and the alternate hypothesis. You all know that. So the null hypothesis is that these two distributions are similar. The alternate one is that two distributions are significantly different. So if the D right here is big, and you have enough samples to prove that D is big, that means the p-value will be low and you can reject the null hypothesis. That means the two distributions will be very, very different from each other, right? Okay, so let me show you an example of this. So first of all, let's talk about one sample case test. So here you have two data sets. As I said before, that in one sample case test, we try to see if two data sets come from a different distribution or it comes from the same distribution. So we have A, we have B. These are two data sets. Now, these are very, very small. Your data sets need to be quite big, like 30 samples or something. But just for this example, we are going to use this. So the first thing you need to do is you need to merge A and B. You need to merge A and B and sort them. So you can see that we have merged these and sorted these nicely. And then you can get the ECDF of A. For example, here at x equal to 1, the ECDF of A is 0 because there is no value in A that is less than or equal to 1, right? That means zero values, so it is 0. Similarly, if you look at here, if you look at the ECDF of A at 6, you can see that there are 1, 2, 3, 2, 3, and 5. These three values are less than or equal to 6. So the ECDF of A will be 3 out of 4, so which is 0.75. Similarly, you can get ECDF of B. Now you can get the difference, right? 0.25 minus 0, 0.25 minus 0.25, and so on and so forth. So it's an absolute difference, by the way. It's an absolute difference. So here you can also see 0.25. So you can see the max difference is 0.25. So your D will be 0.25. You have four elements here and 1 equal to 4, and you have four elements here and 2 equal to 4, right? So not a lot of power you have because your sample size is very, very small. So p-value, what is p-value? P-value is nothing but probability of seeing a difference of greater than or equal to 0.25 when the sample size per list or per dataset is 4, right? That is p-value. Now, how can we calculate this? One way is to just do it like the permutation testing. So in the previous video, we talked about permutation testing. We can sample from these datasets many, many times, and we can simulate what is the D for different sampling. But that can be cumbersome. So there is a direct formula as well, which I'm not going to show here because that's not the important part. But that formula depends on D, N1, and N2, as I said before. So if you have a bigger D and bigger N1 and N2, then there will be a higher probability that you will get p-value less than 0.05 and it will be statistically significant to reject the null hypothesis, right? And then A and B will be different. Okay, now let's talk about two sample case test. So in two sample case test, suppose we have this data set and we want to see if this data is normally distributed or not, right? And it can be any other distribution as well. Just for this example, we are saying normally distributed. Now for each probability distribution, there are some parameters. So we are going to calculate those parameters from X. So for normal distribution, it is nu and sigma, right? Mean and standard deviation. So you can get these values from this data set. Okay, now what? Now we get the X, we sort them, we get their ECDF. Now we can also get the normal CDF, right? So you know that there is a formula for normal distribution. I mean, there is a video as well in my probability distribution series for normal distribution where I showed how to get the CDF of that. So I will leave a link in the description of that as well. But typically, I mean, there are software library and many other things you can use to get the normal distribution CDF. So if you just plug in 1.2, that formula will give you the normal distribution CDF, and it is available for any probability distribution almost. So you have these values right here for these different x's. And now the difference is this, right? Difference is this. So 0.13 is the d equal to 0.13, and there are n equal to 5 samples. So based on these things, you can get the p-value. And I mean, as before, if the p-value is less than 0.05, then this distribution right here, normal distribution, are significantly different, right? So that's the end of the video. If you like the video, feel free to subscribe and share, and you can donate to our channel via the link in the description. So thank you very much.